Hello and welcome to the fifth episode of the Space from Home podcast. My name is Daniel Verscharen and I'm a lecturer in space plasma physics at the University College London's Mullard Space Science Laboratory. In this podcast, I tell you a little bit about the work of space scientists and engineers during the time of the COVID-19 situation. The teaching and training of the next generation of space scientists and engineers is an integral part of the activities in our field. In most cases, this teaching and training happens at universities. Given the COVID-19 lockdown, this teaching cannot continue as usual, and new methods had to be developed. When the universities in the UK, for example, shut down in March, there were about 2 teaching weeks left in the term. Most courses moved swiftly to an online format by using Zoom or other online delivery tools. Of course, there wasn't enough time to design a dedicated online course or to really devise an online teaching strategy. As a further complication, the format for our exams needed to be changed because we could not have hundreds of students sit their exams in one big hall as we did in the past. Instead, we had to come up with longer online assessments, some of which are still going on at the moment. Since we probably can't go back to normal classroom teaching in the next academic year, the universities are currently planning various online formats and a better structure for the online delivery next year. For instance, we know that it is very difficult to follow a long online lecture in front of your computer screen. Instead, we will have shorter recordings, almost like this podcast, plus some active learning activities and online discussions. It will be quite different from the normal way of running university teaching, but I'm quite confident that we can still give the students a good learning experience. Another important part of our teaching activities includes the training of postgraduate research students. These are students working for their master's, like an MSc degree, or for a PhD degree, a doctorate, in our field. This work usually includes work on an individual research project in which the students investigate a research question in the field of space science and engineering with the goals of acquiring new knowledge and of learning the methods to acquire new knowledge. Although a lot of the research student activities involve independent work on the student side, guidance by their academic supervisors is very important. Therefore, we have set up very regular, usually weekly, virtual meetings between the students and their supervisors. At these meetings, we discuss the current status of the project, the next steps, but also how the students are coping with the COVID-19 situation in general. Some of them are far away from home and somewhat isolated, so I think this form of contact is particularly important in these days. Last week, I've organized a solar wind workshop for our MSc and PhD students at the Mullard Space Science Laboratory. The original idea was to hold this workshop in person in London. However, that has become impossible, as you can imagine. Therefore, we moved to an online format where the students could show their work to each other and discuss. I would like to highlight some of the students' projects in this episode. Of course, this is only a very small selection of topics that space science and engineering students work on. I've only chosen those projects that I'm involved in, but there is certainly a lot more going on, as you can imagine. Before starting with the student contributions, we had an introductory presentation by Professor Christopher Owen. He is the principal investigator of the SWA instrument on board Solar Orbiter. Coincidentally, the day of our solar wind workshop was also the day on which the Solar Orbiter spacecraft reached its first perihelion. This is the closest distance of a spacecraft from the Sun on its orbit. Since Monday, the 15th of June, the spacecraft is now flying away from the Sun again for quite some time before it will return later this year. At the same time, the 15th of June marked the official beginning of the so-called cruise phase, so the science operation of the spacecraft has begun last week. Chris gave a great overview over the different instruments on Solar Orbiter, and especially the SWA instrument that is measuring the particles in the solar wind. This instrument is recording data now, although we're also still in the process of learning how the spacecraft works and how all the different instruments work together. Despite all the planning before the launch of the spacecraft, there are always things that run a little bit differently once it's up there in space, and that is completely normal for a space mission. After this presentation, we heard the first student presentation. It was given by our MSc student Benjamin Creton. He has designed and planned a novel instrument design to measure space plasma. This new design is based on the magnetic deflection of the charged particles in the plasma. Although this instrument can only look into one direction at a time, it operates much faster than previous instruments. Such a fast plasma instrument really has the potential to change our understanding of fast physics processes in the plasma. His project is an example for a space engineering project in our program. The next presentation was given by our PhD student Joel Abraham. Joel's research project investigates the evolution of electrons in the solar wind. He studies measurements recorded by the Parker Solar Probe, NASA's latest flagship mission to the Sun. In the coming months, he will use what he has learned from Parker Solar Probe to push our understanding of solar orbiter measurements forward. Electrons are very difficult to measure and possibly even more difficult to understand. Therefore, we require the best data quality we can get to understand the electrons in the solar wind. Meir Bakrania is another PhD student in our department. He applies machine learning methods to classify and understand measurements of space plasma. This diagram from his presentation shows electron measurements recorded by the PEACE instrument on board ESA's cluster mission in the solar wind. Usually, these diagrams need to be studied on a case-by-case basis by looking at the data individually. Meir's method automates this process. It is based on computer models that are also used, for example, in pattern or facial recognition codes. Machine learning is very powerful for the analysis of large data volumes. Afterwards, we heard from another MSc student in our program, Moyez Shima. Moyez also analyzes data from the Parker Solar Probe. He is calculating the dispersion relation directly based on these measurements. As you may remember, I spoke about dispersion relations in episode 3 of the SpaceFromHome podcast. Based on the measured data, he analyzes how plasma waves behave in this measured plasma and how the plasma can become unstable under the observed conditions. Our PhD student, Song-Yob Jung, then presented his work on quasi-linear theory. His project is a theoretical physics project focusing on the solar wind. Through a complicated set of mathematical equations, Song-Yob studies how particles and waves interact in a plasma. There are many interesting resonance effects in plasmas that are important for these interactions. This work will ultimately help us to understand how plasma waves, like those studied by Moyez, give their energy to the particles and heat them to the observed temperatures. After Song-Yob's presentation, we heard from Jefferson Agudelo, another PhD student at MSSL. He uses very large computer simulations to model the evolution of the solar wind. These simulations are huge computer programs that run on high-performance supercomputers. In this way, he can basically set up a plasma in a computer and study how it evolves with time. The results of these simulations can then be compared to observations from spacecraft. This picture shows the result of one of his simulations. He focuses on two very important processes in the solar wind, turbulence and magnetic reconnection. Both processes are believed to be crucial to explain the energy transfer in the solar wind. We finished our solar wind workshop with a presentation by Robert Wicks. Rob is a colleague from Northumbria University. He's one of the world's leading experts in the field of space weather. In his presentation, Rob discussed the impact of plasma on the Earth and on our technology. This talk gave a great perspective for the participants to understand the broader context of their research projects better. I will record a dedicated episode of this podcast about space weather in the future because it really is a very important topic. I must say that I'm deeply impressed by the students and their projects. Under normal conditions, research students always play a critical role for the advancement of our field. During this phase of an academic career, researchers can really focus deeply on a detailed research project. Of course, we were all unsure how this would be affected by COVID-19. Under these really difficult conditions, we couldn't expect that student research would progress as normal. However, I'm really impressed how our students still push the frontiers of our field forward, especially given these difficult circumstances. If you like this short look into Space from Home, please like and share this video, and then hopefully I'll see you around next time. Until then, take care and stay safe. Goodbye.